All right, 1.4 day 1 of solving inequalities. Our objective is to solve and graph inequalities. So let's get going. Put all the notes up there. An inequality contains, gotta turn my pen on. An inequality contains the symbols less than, greater than, less than or equal to, or greater than or equal to. Solutions of an inequality are the numbers that make the inequality true. An equation has one solution, whereas an inequality can have many solutions. Remember that when you are multiplying or dividing an inequality by a negative, to reverse or flip the inequality sign. All right, here are those notes about open circles, closed circles, shading left, shading right. So you just need to fill in what symbols, open, closed, left and right. The whole part about the shading, I would make a special note that this only applies if the variable is on the left side. All right, our first step is to solve the inequality, then we'll worry about graphing it. We solve inequalities much like we would solve equations. So we're getting the variable by itself, preferably on the left-hand side. So for example 1, my first step would be to add 6 to both sides. So I have 3x, I keep that symbol the same, less than 33. We divide both sides by 3. Again, our goal is to get x by itself. So we have x is less than 11. All right, now we move on to graphing. So I'm given this blank number line. I have to figure out what to fill in. 0 needs to be on your number line somewhere. It does not have to be smack dab in the middle. Since I know I'm working with a positive number, not a negative number, I'm going to put my 0 down towards the left side. Okay, and then I personally am going to count by 2s. 2, 4, 6, 8, 10, 12. Okay. I counted by 2s. If you want to do it by 1s, go for it, but you're going to make twice as many little dashes. But I need to graph x is less than 11. So where am I going to put my circle, my point?
Between 10 and 12.
Very good. Right between 10 and 12. That's where 11 would be. So I'm going to put a point there. Let me use a different color. Am I going to put an open point or a closed point? Open. Leave that point open. That color did not show up well.
Why is it open?
Good question. Why is it open? Very good. Less than and greater than signs, or signs without the equal to bar under them, are open circles. Then we have to decide where to shade. We're going to shade to the left or to the right? To the left. Okay. So, yes, if you can sing a song in your head if you want to. Shade all the way down, including that arrow. Yes, that's what we mean by shading. You shade in the line. It doesn't have to be super neat. Mine's kind of sloppy, squiggly. That's fine, as long as it's obvious that it's shaded. do not do one of these. Okay, that's a nice little notation as a hint to yourself of what's going on. That is not a correct answer for this type of problem. Okay, we might use some of that shorthand later on, but not today. And that shorthand will never be our final answer. Here we go. On number 2, we have 122 is greater than or equal to 3n minus 1. Sorry, plus 1. Thank you.
No problem.
I was focusing more on the fact that we have these parentheses here. Do those parentheses serve any purpose?
No.
No, they don't. So we can kind of just ignore them. And the first thing we are going to do is subtract 1 from both sides. Beautiful. We have 121 is greater than or equal to 3n. Then we have to divide. We got a decimal. Okay. So, all right. So, normally I would want you to leave your answer in this form, right? If it doesn't come out nicely, I don't want you to round it. But because we're putting this on a number line, let's go ahead and put down 40.3 repeating. We need the bar over the 3 to show that it's repeating. And this will help us graph it more than the improper fraction would. All right. So it's time to graph our solutions. Again, I know I've got a positive number, so I'm going to put 0 down towards the left. Somebody suggested that we count by tens, and I like that idea. 10, 20, 30, 40. Where is my point going to go?
40. Behind 40 just a little bit.
Why is it not on 40?
Because it's 40.3.
Wonderful. It's not exactly 40, it's 40.3 repeating. So it's going to be just a little bit more than 40. Is it going to be shaded in or open? Shaded in. Closed circle, closed point, just after 40. It might be a little hard to see from your desk. When you put points on there, make sure you're not just putting like, beep, a little dot, right? Make sure I know where that point is. Don't make it take up this much space, right? Like we don't want those kind of points. But I want a nice, solid point. Then we have to decide where to shade, which on this one is a little more confusing.
Right.
So I have people saying to the right, but my variable is on the right-hand side.
Right.
So we're going to have to flip this around to get the variable on the left. So we pick up the whole thing and turn it over. So that would turn it into n is less than or equal to 40.3 repeating. Notice how the little arrow part of it is still pointing at the n when we pick it up and flip it over. When the variable is on the left, that's when we can use that little chart to help us. So maybe put a star by this one and make a note of that. You had to pick it up and flip it over. Good job. So now, which way do we know we need to shade? It's not to the right. To the left.
Why?
Because it is less than. When our variable is on the left, it is n is less than or equal to 40.3 repeating. Another way to check this would be to pick a point in your shaded space and plug it in. A point in your shaded area should make the statement true. For example, we could pick 0. The 0 is in our shaded space. If we plug 0 into either of these, the original one or the one where we flipped it around, we should get a true statement. So here, if we try out 0, we would have 40.3 repeating is greater than or equal to 0. Well, that's true. 40.3 repeating is greater than 0, so that works. The same thing, would happen here if we plug it into n. 0 is less than or equal to 40.3 repeating. So I know it works. I got it right. I'm going to take example 3 and rewrite it towards the top of the slide so I have room to work it out. So I'm just going to bring it up here. Negative 2x is less than 3 times the quantity x minus 5. On this problem, do I need the parentheses? Yes, I do, because what do I have to do? Distribute, multiply it in. So that should be our first step. Negative 2x is less than. When I distribute that, I get 3x minus 15. All right, to continue solving, I need all my variables on the same side of the equation. So I am going to subtract 3x from both sides. That gives me negative 5x is less than negative 15. If you wanted to move the negative 2x over to keep it positive, you can do that, but then you're going to have to add the 15 back over to the left-hand side. I just think that gets messy. Let's just leave the negative 15 alone. Until this step. This step is an important step, something we haven't seen quite yet. We have to divide both sides by what? We are dividing both sides by a negative 5. And there is a special little note about when we multiply or divide both sides by a negative, something special happens. Well, we do end up with a positive 3. Positive x plus. What happens to this sign? Flips over. Our inequality sign flips over when we multiply or divide both sides of the inequality by a negative. All right, our last step then is to graph. This one, our number line should be pretty easy to create. 1, 2, 3. I have to decide, do I want an open or closed circle at 3? Open. We do not have an equal to bar, so it is open. And then I have to decide, do I shade to the left or to the right? To the right. Our variable is on the left-hand side, so we can trust the way our inequality symbol is pointing, and it is pointing to the right. Another way that we can check to make sure we did this correctly is to pick a point that would be in the shaded area. So like 4 would be the next point. We can plug 4 in and see if it makes a true statement. Is 4 greater than 3? It is, so that means we shaded the correct place. All right, example 4. 7x is greater than or equal to 7 times 2 plus x. Once again, we have a problem where we need to distribute first. So let's start off with that. 7x is greater than or equal to 14 plus 7x. Some of you are already saying, this looks interesting. When I go to get my variables all on the same side, let's say I want to move this, I would subtract 7x. But I have to do that from both sides. So what do I end up with on the left? Ooh. I heard a lot of interesting answers. The correct one being 0. On the right, we have a 14 left. That is correct. All right, so this looks a little weird compared to our last ones. This is normally where we would start graphing. But what disappeared from our problem? The x. The x is all gone. When that happens, there are two different situations which could possibly occur. Either you will end up with a true statement, or you will end up with a false statement. The statement we ended up with is 0 is greater than or equal to 14. That is a false statement, which means your answer is to say no solution. Which means your graph should be left blank. You could put numbers on your graph if you want to. You could put a 0, a 1, and a -1, but you should not graph any points. You should not shade anything. The answer is that there is no solution. You get a false statement when your x disappears. There is no solution. There's no number we could plug into x that would make a true statement in the beginning. Number 5, 2x is less than 2 times x plus 1 plus 3. Again, our first step in a problem like this is going to be to distribute. Wonderful. 2x is less than 2x plus 2 plus 3. And I'm like, oh, these are on the same side of the problem. They are like terms. I would like to combine those. I would say that is a fantastic idea. Go ahead and do that. Then we start working on getting all of our variables on the left. So that leaves just our constant on the right. When we do that, we subtract 2x from both sides. And we notice something strange happens again. Somebody said 0 is less than 5. Once again, we had 2 x's. We took them both away. We have 0x or just 0 left. But this time, what do we notice about our statement? It is true. When you get a true statement, your answer is all real numbers. Bless you. All real numbers. Ooh, we can't see that very well. Down here, this says all real numbers. There is a symbol to represent all real numbers. It looks like this. The double barred R. That symbol represents all real numbers. So instead of writing out all real numbers, you can put that symbol. And when we go to graph it, say we put 0 there. Our graph for this, it's not empty. Everything gets shaded. The whole thing from front to back gets shaded in. So we don't have to like put a single dot somewhere or worry about open or closed circle. The whole entire number line gets shaded for all real numbers. All right, example 6. Once again, they want us to distribute first. So we will do that. 4x minus 12 plus 7 is less than or equal to 4x plus 1. I think, I'd like to combine like terms. So we have 4x minus 5 is less than or equal to 4x plus 1. I want all my variables to be on the left-hand side. So to do that, I subtract 4x from both sides. I'm going to move my answer up to the top here. What do I get when I subtract 4x from both sides?
0.
So the x's all go to 0. That's correct. What am I left with?
You're left with -6 is well, can't you subtract the 1?
Well, let's just do what's already there. You are right. You could subtract the 1, but let's just do what's already there. -5 is less than or equal to 1, right? There's still a 1 over there. Okay, so the question was asked, couldn't you subtract the 1? Yes, you could, but you do not have to. Because right now we can evaluate this statement as being true or false. You don't have to involve 0. You can if it makes you feel better. But at the moment, our statement reads -5 is less than or equal to 1. And we would say that is true. So because we have a true statement, our answer is all real numbers. And our number line is completely shaded. Very good. So when you answer these, you don't have to put true or false. I just think it's helpful to remind myself, like, if it's true, I know it's all real numbers. If it's false, I know that there is no solution. In the past, though, I've had students who have just started writing true or false. That's not a complete answer. That's just leading you to your answer. A real estate agent earns a salary of $2,000 per month plus 4% of the sales. Find the sales if the salesperson is to have a monthly income of at least $5,000. Okay. So we want her, him, whoever, the salesperson, to make at least $5,000. They get income 2 ways. They get $2,000 right off the bat and 4% of the sales. So when we go to write an inequality, I'm going to take the money that they make. I want their money to be greater than or equal to $5,000. You don't have to write this part down. This is just how I think through the problem. If it helps you, that's wonderful. To calculate the money that they earn, we know they're getting $2,000 plus a percentage of the sales. So I need that percentage to be in decimal form, and I need to multiply it by the sales amount. I don't know what it is, so I'm going to use a variable x. That is how the money is calculated. And I want that amount to be greater than or equal to $5,000. This equation here, the second line that I wrote, that is something you would need to have written down. And on some problems, you are going to be expected to come up with that sort of an equation, or inequality, rather. Now our next step is to solve this. I'm trying to get x by itself, so I am first going to subtract the 2,000 from both sides, leaving me with 0.04x is greater than or equal to 3,000. And then I have to divide it, both sides, by the 0.04. So I end up with x is greater than or equal to
75.
just 75?
75,000.
75,000. Okay, sorry. No, that sounds better. So that's it. That's our answer. The sales that they would have to be greater than or equal to $75,000. So you could say that the sales needs to be at least $75,000. So that could be like one $75,000 house or 3 different $25,000 houses. Whatever it needs to be, sales have to be at least $75,000 to make that income of $5,000 a month. Number 8 technically has multiple answers with the way that it's worded. Find the lesser of 2 consecutive integers with a sum less than 25. So I want my 2 integers to add up to something less than 25. I want them to be consecutive, which means one right after another. Okay. So if I call my first one x what would my next one be? X plus, I want the very next number. How many do we add every time we count? 1. Okay, so if I start with x, the next one after that is going to be x plus 1. So these are my two numbers that I'm looking at. And when I add them together, take the sum of them, I want it to be less than 25. First thing I want to do now is combine my like terms. X plus x is 2x. So 2x plus 1 is less than 25. We subtract 1 from both sides. We have 2x is less than 24. We divide both sides by 2. We get x is less than 12. So what that means is that our number has to be less than 12. So give me a number less than 12. 11. So if we said that x is 11, and then x plus 1 would be how much? 12. That would add up to something less than 25. Right? So my answer could be 11. Or somebody else said 10. Well, sure. 10 plus, what is 1 more than 10? 11. That is still less than 25 when we add them together. So 10 is also a possible answer. Okay, so really any number less than 12 is going to work.